We have an amazing guest today, Ofer Mendelevitch. Thank you so much for being here. What motivated you to write this book?
First of all, thank you, Vicky, for having me. I'm so excited to talk to you today. My background is in machine learning and data science. There's things we called AI before it was called AI, maybe 5 or 6 years ago. I've been doing it here in Silicon Valley for a long time, and I was lucky enough to get introduced to the world of LLMs around 2019, quite early, before the big launch of ChatGPT, and worked on actually, believe it or not, GPT-2, just as it turned from GPT-1 to GPT-2. Actually, it was called GPT. It wasn't called GPT-1. It was just called GPT, and then
The
they said, "Oh, we
original
got another one."
GPT. Yeah,
Yeah.
makes sense.
So I worked on it for a while, and around 2023, I joined a company called Victara, which is a RAG and now agentic platform for big companies, big enterprises. And I worked a lot on RAG in the early days and really saw a lot of what is going on. So I want to know stuff based on like 10 documents, PDFs, or whatever. We used to call it chat with my PDF kind of thing.
Yeah.
And I learned a lot about how to scale this to more complicated use cases, multimodal data, things like this. And at some point, O'Reilly reached out to me and said, "Hey, we'd like to write a book about this. Would you want to write this?" And so I, talked to him for a while about this, and eventually decided to jump in and do this. Really distilling a lot of my experience for working with customers, working with people who are developing not just simple demos, but real things in production, and kind of share what I've learned as much as it's valuable to readers. That's really was the idea behind the book.
Yeah, you work very closely with developers, right? Primarily as part of the kind of developer relations. So that you hear from developers all the time. Is it production ready? And so, what are the things that you usually encourage developers to do if they're building kind of agentic production ready RAG systems?
Yeah, well, there's a lot to unpack there. But I would say this. First of all, think about production as something that has to be stable. So the usual production things, of course, apply. You have to have latency should be low. It doesn't crash, of course, things like this. But specifically, the book doesn't focus on those standard systems things, right? Although there's a little bit of that, mostly around things specific to RAG and agentic RAG. So that means things like advanced techniques for retrieval. RAG is very, very sensitive to the types of retrieval pipelines you build into it because you want to get the most accurate results. And to do that, for example, people start with a vector database, and sometimes you need a re-ranker to make the results even better, or different types of re-rankers. How do you deal with what's called multimodal data in RAG, like images and tables, maybe audio or video information? One of the difficult things is how do you evaluate the results? So you can say, I built a great system, but how do you know? Okay, so maybe you do a couple queries and you test it. Is that systematic? When you get to production, you want to have kind of a framework to evaluate your RAG continuously. And every time you make a big change or you add something, you want to evaluate it against the baseline and show that you've actually improved things and not, regressed the quality of the results. So those are a lot of the things that we talk about in the book. There's also things about knowledge graphs. And so knowledge graphs have sort of recently been discussed more, and they're a way to deal with more advanced queries that sometimes like your vanilla RAG pipeline just doesn't deal with well.
Tell me more about, I mean, RAG was very popular when kind of you mentioned ChatGPT came out because people really wanted to augment the quality of the data they had in the LLM with their own data to make it a better outcome. Do you feel that's still as valuable as now we've moved on to these models that are trained on so many more tokens and so much more data? Is RAG still as applicable as it was before and valuable for enterprises?
Yeah, 100%. So the main idea, right, of LLMs train on publicly available data in the web, and there's always the need to have it be able to answer based on information that it doesn't have access to, which is your own private information, your company's information. Now, RAG started as maybe a simple technique, so RAG stands again for retrieval augmented generation. So retrieval, this idea that I have all the data of the company indexed somewhere in a place we call the vector database, of course. And then you pull that information using semantic search, you retrieve it, and you take the top, let's say 5 or 10 or 100 most relevant documents to answer the question. You augment the LLM, and that's where we get to the G part, the generate part in the RAG. And you generate a response based on very relevant information. You provide the LLM sort of in real time when the query comes in. So that's kind of how RAG works. Now, agents is almost like a natural extension of that. It's much more powerful in the ways that I'll describe in a minute, but an agent is essentially a loop of retrieval, evaluation, until you get to the generation part. Mm-hmm. So it's but the retrieval is not just from data sets that you sort of put data in, like PDF documents and things like this. It has access to what's called tools. And tools are, they can be a call to a REST API, they could be Python function, they could be a lot of different things, including retrieval from the kind of traditional RAG. So the idea that some data sources still require the same RAG retrieval pipeline is still very valid in agents. And in order to do this in an enterprise, you have to have that. But you have that now as a tool among other tools. And the power of agents also comes from the fact that there's a loop, right? So the agent says, you give it a query or a task and you say, I want to answer this question. So it goes and calls a bunch of tools and it gets the results and it processes them and says, do I have all the things I need? If not, I can call same tools with a different query or some other tools. And it does this in a loop until it satisfies all it needs to really answer your question. But the tools can also be actions. So a tool, for example, could be used to send an email or pay an invoice or something like this, right? So it can become more proactive, not just answering questions. And that's another kind of way to move forward that's happening right now.
So tell me more about agentic, because now we're talking about agents, we're talking about agent orchestration, where you have multiple agents or an overhead manager that orchestrates a bunch of lower agents. How do you think about RAG in that context? Because is there different data kind of exposed to different type of agent? Is there, should you be thinking about a different large language model based on the context of what you're trying to augment?
So the way I think about it again is like RAG kind of, expanded into agentic workflows. Yeah. And it used to be like a one shot. You do one retrieval and then generate the answer, and that's it. That was the RAG of 2 years ago. And now in agents, you're sort of like, you call different tools and some of them are going to do the same. So the retrieval part remains really powerful. Right. If you don't get the right information from the retrieval, then the generation and how many times you loop through it, it's not going to do a different answer. It's not going to get the right answer. So the retrieval part of RAG remains very important. And in the book, we cover a lot of this, how to build the best retrieval, because it's also very important for RAG. So it remains a very important part of what you can learn of how to do well when you build agentic parts. The new thing that's happening with agentic now is there's also, the loops are becoming these harnesses. So if you think about like a Claude Code or a OpenClaw or something like this, these things they would call them harnesses now because they're a little bit more than a loop. They become a little more opinionated about how to do stuff. And sometimes one agent can spawn multiple agents, maybe sub-agents. And a lot of times the agents work in parallel. Sometimes they work step by step to do more regulated, gated items. So there's a lot of different patterns of how agents work with each other and how they collaborate with each other. And that's a big pattern of agentic as well. But the core idea that if you have to have, let's say, all of your Google Drive information or information from PDFs or any text, unstructured information, the best way to include that in agentic workflow remains building this very, very complicated RAG stack that actually performs well in production, that you can judge its performance, its accuracy, etc., to power these types of queries. While at the same time, you have other types of tools that are not sort of retrieval in nature, that go to APIs and things like this to get different types of information. A good example of that is text to SQL, right? So now we have this idea of, I want to type in, I don't want to write SQL, I don't want to learn SQL, it's too complicated, it takes too long. So what if I was able to write a sentence in natural language, for example, and say what I want, and then it translates that into SQL, and then SQL runs against a database and gives me the results. For example, what is the revenue of the last 12 months, right? Or something like that. So now agents can have tools that are text to SQL, and those tools will get the sentence, what is the revenue in the last 12 months? will automatically translate it into SQL, run it, and give you the result back to the agent as part of its execution, right?
Right. No, that makes a lot of sense. I've actually come across that example. There's Grafana dashboards, right, that kind of pick on the data. And we were so used to building static dashboards that show us information like the revenue over the last 12 months. But to your point, if you just want to use natural language, you could say, oh, what was the revenue over the last 12 months? But today you need it for the last month. You can change that query very easily. It doesn't have to be static.
Yeah, now there is, I would say, just to be fair to where we are today, like this doesn't work 100% yet, right? There's a lot of benchmarks, and SQL is a complicated language. And one of the challenges I see kind of the next year or so is the idea that sometimes you don't, the LLM has no context, so to speak, in terms of, so if I say, what is the revenue in the last 12 months? Maybe I define revenue including this item or not including this item. So there's a lot of meaning or context for this particular company. Maybe a better example is not revenue, but what if I say, how many people have defaulted on their payment, right?
Right.
Is default that you haven't paid in 15 days or 30 days? Like, well, how is it defined? And every company have their own definitions. And so a lot of that context really has to be defined for text SQL to work well, but that's a topic
So this
for another.
No, I like that topic. It's a contextual layer. A lot of people talk about like building an additional layer where you have that sort of knowledge already residing that agents can essentially leverage, right, in their thought process. The only thing that I'd love for you to explain to me is I love the premise of contextual layer, but where does it live within the architecture? Like when we think about RAG architecture, where does that context live across everything?
So I want to differentiate two types of context people talk about.
Sure.
There's the context I mentioned in the sense of text to SQL first, which is the, think of it as just database, structured data.
Yeah.
What's the meaning of the word revenue? What's the meaning of the word default? What's the meaning of things like this? And this is really a definition, right? Like when I turn it into SQL or something like this, like where do I look? What does it turn into tables? There's also the word context is now heavily used in a different way in industry, in a sense of what do I feed the LLM? Okay. So there's a different thing. So imagine your agent or your RAG pipeline or both, right? And you have a million tokens of context in LLM, in modern LLMs, in terms of how much tokens you can feed it before you ask it a question. And so the idea of context management means out of everything that I can feed into this thing, so I feed it a lot of, let's say, the retrieved results or anything like this. Of all of these, what should I feed it? If I feed it too much, maybe I'm adding noise and kind of poisoning the context a little bit. But
Hmm.
if I feed it too little, it may not have the right information. It's still limited. A million tokens sounds like a lot, but it's probably a couple of books. I mean, it's not that
So
a
how do
lot. You
you
can't feed it.
decide what to put in and what to keep out?
So that's where retrieval and accurate retrieval comes in handy, right? If you just forget about all other types of context, we talk about the RAG type of context, we talk about in the beginning, the retrieved documents. Having very accurate retrieval means you can select the most important things to feed in, right?
Hmm.
But at the same time, what you see now, especially with agents and when the things become a little bit bigger, is you have historical context too. So you say like, if I talk to a chatbot for 5 hours, maybe I include some of our conversation so that if I ask a question like, let's say we talk about the book and I say the book is called Hands on a Rag and da 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 da. And then I say, I ask as the human, what do you think about the book? It needs to know that I'm talking about that book we just talked about in the last 5 hours as opposed to some book, right? So there's a context of kind of short term history.
Yeah.
And now a lot of the chatbots like Claude and ChatGPT and Gemini, they actually also store like longer term memories. Like if I talk to you a lot about books, they'll say like Ofer is an author of a book and kind of like put that somewhere in its like
Yeah.
long term brain. And also that needs to be retrieved accurately at runtime. So there's general context of company information. There's
Yeah.
short term and long term memory, and there's other types of memory people talk about. And all of that needs to be retrieved accurately in the right time in the right place. So to answer your question, how do you do that?
Right.
It's a little bit of an art and science that people are sort of playing with right now.
Are there any
And
best
there are some
practices or
experiments.
patterns? Any like one? thing that works well that you found?
Well, first of all, you gotta figure out which types of memory you want to keep, right? Of course, the company, but the short and the long, so first of all, you gotta figure out what to keep. But what I've seen most people do is on short-term memory, you sort of wanna you don't want to make it too long. You want to say like the last day or the last hour or the last sessions. If you start different sessions, you only limit to the same session.
Hmm.
But one pattern is people compress the memory. So once it becomes too long, the LM on the side runs a parallel job that sort of tries to distill all this long conversation to like individual smaller facts that it wants to remember and replaces the really long context with a shorter summary, if you will. And that's
Okay.
a really good pattern.
Interesting. No, I really like that because as we get more and more data and more ways, more complexity into this environment, right? We have to think of token management, which becomes really critical. Context caching is one of the patterns I'm seeing in the industry right now, is everyone worries about that, so they don't use as many tokens for the same type of query.
Right.
And then the one that you talked about in terms of memory, how much memory is long enough to keep, or some of the memories maybe are worth throwing away, right? And making that decision at the architecture
Yeah.
level.
Yeah. And
Yeah,
so there's a lot of stuff. It's not only the cost, it's also the latency. The longer the context is, it takes much longer for the LM to respond. And a lot of use cases
yeah,
are latency sensitive. They want to get the response not in 10 seconds, but in 1 second, right?
right.
So it's got a lot of
What are
implications
some
across the
latency
board.
sensitive examples that you can think of that you worked on, and how did you reduce latency?
Yeah, so let's see. First of all, if you're a chatbot today, there's sort of all of us expect ChatGPT and Gemini or whatever to respond within a few seconds. If it takes 30
Right.
seconds, we're like, oh, is my internet down? Right?
Yeah.
So even the B2C kind of
Search has
general,
spoiled us. Google search spoiled us.
exactly. So this is just a general thing. Let me think in an enterprise setting, right? I mean, every customer service would sort of have the same expectation, I guess.
Yeah.
And also remember that what we're starting to build now is multi-agent systems, right? Where one agent calls another agent and that calls another agent. And so if they all start having a low latency, it starts piling up.
Hmm.
And you might have timeouts someplace and the timeouts run out and say, oh, this agent didn't respond in time. So I'm going to reset everything and try again. And that creates these rolling problems, right? These self-amplifying sort of retries and all this stuff. So that's not good. I think, is there any
So is it better
use
to
case?
place the agent? So I work for Akamai, and we talk about
Okay.
network latency all the time. And
Okay.
so our big spiel is always, you're one hop away from the customer. Cache as much as you can closest to the customer because the latency is reduced as a result of that. So my question is, one of the things we're testing out, is it better to be closest to the customer in terms of agentic physical location, right? In terms of network, or is it better to be closer to the large language model that you're calling because those servers might be deployed in California, but your customers in Atlanta? Or do you place all agents in the same kind of area close? How do you think through that? Because we thought through that through, web pages. We know that we can put web pages closer to the customer. It will load much faster, especially we have a cache of that page and it doesn't have to go to the origin. Is it the same consideration for agents and placing those closer to the customer?
I think the LLM latency is still primarily in the LLM. So I think you want to be close to the LLM, in my opinion, at
Okay.
this point in time.
Yeah.
However, let's unpack this a little bit more, right? So there's also the idea of AI sovereignty, right? I don't know if I'm
Yeah.
pronouncing that correctly, but
You are. I know what you mean. Yeah.
which is maybe you want to have your own LLM or an open weights LLM sitting next to you.
Yeah.
On the one hand, that gives you more control over latency, and where you put it, you can put it closer to the
On your
final
machine, for
agent,
example, right?
the
Like,
machine.
yeah.
Yeah. So that,
Yeah.
and that also gives you we know that the LLMs now, sometimes they'll go down. They'll be offline for a half an hour. And so there's a lot of movement towards sovereignty because of many reasons. But one of them is so they want to be in control. And the API providers, they're doing a fantastic job in trying to keep it all up. I'm sure
Yeah.
trust me, I don't want to be in the shoes of the DevOps people who are sort of keeping these systems up, right?
Right.
Uh,
Right.
but at the same time, it's not perfect. And so if you have a mission critical system that is responsible for safety of people or running a lot of money through or something like this, and all of a sudden there's a delay, it could cost you in health of people or in transactions or whatever. it could be a big cost, a big penalty to pay. And
Mm,
so I think being independent of sort of controlling your own destiny is something that more and more companies are starting to think about and building towards.
I love that. Okay. But yeah, it gets expensive, doesn't it?
But yeah, somebody else said it. Somebody else said it, but I totally agree. Like 2026 is going to be the year of cost consciousness or something in token things, right? Because people start realizing, whoa, this costs us a lot. The big
Yeah,
companies that are token maxing or whatever they want to call it.
right.
This is going to be a big reckoning this year, I think.
I think so too. I'm already hearing customers talk about total cost of ownership, total cost of ownership. So that's like the buzzword, at least, of 2026. Show me that you're actually doing what, to save me money.
Like, so I've lived in Silicon Valley for many years, and I remember that, for example, Instacart, which is quite popular
Right.
here in
I
Silicon
still use
Valley.
it. I love it.
I still use it, but you pay some fee for delivery, right? Which is
Right.
fair.
Yeah.
But in the first 3 years of its existence, there was Google had a shopping competing product and a bunch of other companies, and it was all free delivery because they were all subsidizing everybody to learn what the product needs to
They wanted
be and
to the network effect of growing their
get the
market.
network effect. I
Yeah.
think we're still in the subsidy time of AI. Like we have the subscription for $100, we get nearly unlimited use, much more expensive than we pay token by token. So once the unit economics starts to kick in, and they need to like start justifying this as it's gonna be different, right? And
Very
companies
true.
are gonna be even more worried about the cost than they are today because they're gonna see it even a worse situation.
So, what do you see the future looking like? I know that's like one of our favorite questions here is just what is next year, 3 years from now? What do you see?
Yeah, it's of course futures for what's the statement? Don't I forget the quote. Somebody said predicting is for the foolish, especially about the future or something like this.
Yeah,
Some scientist said that.
we don't know.
So, yeah. So look, I think that definitely there's been a lot of excitement around LMs. I think we've gone through GPT-4 to reasoning to now, multimodal LLM, lots of improvements in the inference stuff. I definitely think inference will get better,
Yeah,
faster, cheaper. There's a lot of investment in responding to the demand and stuff like this. And the model will become better too. But I also think that there will be, a lot of progress in agentic workflows, what we call the harnesses, the things that control the agents and make them better. We've seen Cloud Code is a great example, and now Codex is similar in terms of like how a good harness can make the agentic workflow behave really, really well. So I think we're going to keep seeing that. We're going to see the LMs being able to capture, this level of performance for agentic workflows that we see with reasoning models. One of the things that I'm really excited about, though, is so we haven't talked about it a lot, but LLMs now have these three layers of training. They have what's called pre-training, mid-training, and post-training. And post-training is a lot of what made reasoning possible with generating tokens of thinking and all the stuff that we read about. And it's mostly about reinforcement learning. I think what I think will happen, what I'm hearing, is that there's going to be a lots of work on making that layer better to solve more problems.
Hmm.
But it solves reasoning, let's say, of math problems. We all heard about the math problem it starts to solve. But there'll be a lot of other scientific problems that people will train on using reinforcement learning of different kinds. And we'll be able to get the models to do better at other areas. Which ones they will be, I don't know. But I'm really excited to see what else it can help us solve as a society.
Hmm. So, do you think it'll be more specialization? Like, do you see more specialization in terms of, or how do you see that progressing? I guess, are we going to become more general? Like, right now, we're very general, right? In terms of large language models, have everything and about everyone and everything. But do you see it becoming smaller models, kind of winning the day with specialized knowledge?
So that is a good question. I don't think so. When you say that, I'm thinking in my head like, would vendors like OpenAI and Anthropic start creating like 50 types of models, one for each
Right.
area?
Like
I don't
healthcare
think.
and biotechnology. I don't know, like,
Yeah, yeah, yeah.
genetic
I don't.
engineering.
I think the cost structure of that is really complicated.
Okay.
Not just to train them, but also to sort of how do you expose them in an API creates confusion. I think my guess is, I don't know this, but I think they'll probably try to sort of include it in one model somehow. and to be
Yeah.
able to bring that knowledge set just from a practical perspective.
Hmm.
But for all intents and purposes, it'll behave the same as, yeah, we'll have not just coding and math, we'll have other expertise areas that it'll be able to do. Some of them are really useful for industry, like legal and maybe HR and all kinds of things like this. So the muzzle will become better that way because they'll have more specific skills to sort of be able to work with. And sorry, I'm saying skills, not in the meaning of Cloud Code
Of Claude
skills.
Code. Everybody thinks about Claude Code now, right?
Yeah, regular skills, like we used to say 2 years ago, right?
Right. Yeah, that word.
But I also think you mentioned something else that's interesting. I do think that small models will become more popular. So there is a way there's something called distillation of models, right? Where you can take a big model as a teacher model and then take a really small model like a 1 billion or 4 billion or something like this and train it or continue its training in a way to learn a particular task. And that is useful not to replace the bigger model necessarily in terms of like top performance calibration, more because if the smaller model is equivalent or near equivalent in performance to the larger model, you can imagine being small, it's much faster, much
Right.
cheaper. And so if you can distill your task into something that you do, hundreds of thousands of times a day or something, it's meaningful enough to do that, the ability to build these specialized models that are small is going to be very meaningfully important for enterprises.
Do you see certain industries benefiting from this more than others, like being truly at the cusp of absorbing this and others kind of taking wait and see attitude?
You mean the small models?
Yeah.
Yeah, certainly healthcare, for example, right? There's tasks in healthcare that are they do on many, 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 many patients, like everybody else
And
in
they
the world,
probably
right?
define it better than many others because they have procedures that are written down for every doctor, every
Yeah.
nurse.
So, for example, classification tasks are a good example. I want to know if this is something that's billable to this code or this code or that code, for example. A
Right.
lot of the like, very menial tasks that are done, a lot of it manual coding in the sense of medical codes, right? Translating what the doctor tells you in your appointment to an actual medical billable code for insurance.
Yeah.
Just that's been done a lot manually today still. And so having these very complicated tasks being done today, if you give it to an LLM, it does a pretty good job, but it's pretty expensive and it takes a long time and it costs a lot of money. But if you can distill it to a small model and have it done so that's an interesting use case. There's we started, I mentioned sort of 2 decades of working in the traditional machine learning world. A lot of these tasks have been done using traditional machine learning,
Right.
like classification, like extraction, like summarization. And the ability to do them now with LM has become sort of, people are becoming lazy. It's like I'll put a prompt and I'll say, please classify to these things, and send it to the LM. It's very easy to do. But if you do millions of those a month, it starts costing you a lot of money. And
Hmm.
I think that economics will drive it to be used more.
So, what are you looking forward to finish off this? What are you learning yourself? What do you encourage our audience to learn more of besides getting your book and learning more about RAG models?
If you build production systems, right, and you need to mature it. I'm working in a lot of different areas right now, a lot of work in agentic AI. One interesting area is multi-agent systems and how can agents collaborate with each other? How can they
Is it
work?
harder than humans or easier than humans?
And that's a good question. So I think it'll be easier for them to work together than us because the egos stay out of the agents' workflows,
That's
right?
always better,
They
yeah.
got instructions and they just want to get to. So I can imagine like two lawyers negotiating, right, on behalf of their customers, and there are, we're all human, and so like, agents have like, you're not gonna agree to less than this, you're not agree to more than that, and then somehow they find a middle ground very quickly, right? So I think
Yeah.
that's what I think of when I think about that. But I think there'll be a lot of interesting use cases of agents talking to each other.
Hmm.
I am very curiously following what we talked about in terms of data and how that integrates into agentic systems with text to SQL and things like that. I am, there's so much going on. Like I'm gonna attend if anybody is there. Please come say hi. There's a conference called AI Engineer World Fair in San
Wow.
Francisco next week.
Nice.
I think it grew from like 2,000 to like 6,000 people or something like this from last year, like
Wow.
double. So And there's just so much work being done, so much innovation, so much exploration of new things, and I think it's gonna continue to be a really nice industry to like watch and see what happens, how the LMs evolve, how RAG evolves, how agentic evolves, and yeah, I'm excited to see a lot of the innovation that's happening in the ecosystem.
And you said it's in San Francisco next week, so we'll make sure to
Yes.
get this episode out so people can learn about it.
Yeah, yeah, yeah.
Awesome. Well, thank you so much, Ofer. I
It's
appreciate it.
really
I just appreciate the yeah telling us about the conference and the book. It's very kind of you. And how can people reach out to you if they're at the conference? How do they connect with you?
I'll be walking around. You can connect with me on LinkedIn, on follow me on Twitter. You can, of course, if you're interested in the book, it's available on Amazon and O'Reilly on the platform. I think it's actually not available in paperback yet until July 3rd or July 7th or something like this. But it's available in Kindle and will soon be available. I think it's available to pre-order, but you're not gonna get it until July 7th or something like this.
Yeah,
Yeah,
that's
it's
exciting.
very soon here. I just recently got my author copies, the first author copies, in my
How does it
hands like
feel?
about a week ago. It was very exciting. It was very exciting.
Well, thank you so much. I really appreciate it. This was super interesting. I hope everyone gets a copy of the book. So it's going to be in hard copy in a couple weeks here. So
Yeah,
time's
yeah,
going to
very
by
soon.
fast. Thank you so much, Ofer. I really appreciate it.
Thank you, Vicky. Same here.